Hello everyone, welcome to Vidmahi Maths Academy. Today we are beginning one of the most important chapter in maths, that is class 11th trigonometric function. This chapter is very important for CET, JEE and engineering studies. Don't think it is difficult. If you understand the basic identities and unit circle properly, trigonometry becomes one of the easiest chapter. And if you know only the basic from class 10th, don't worry, we will build everything step by step from 0 to advanced level. Now, let's quickly recall what we studied in class 10th. In class 10th, we define sine, cos, tan, cosec, sec, cot using right angle triangle. Correct? So that consider one right angle triangle. So here this is hypotenuse side and this is angle, it is 90 degree. So that it is called as right angle triangle. And suppose if we consider the angle is theta here, so opposite to theta is called as opposite side and adjacent to theta is called adjacent side. Now sin theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, tan theta is opposite by adjacent, cosec theta is hypotenuse by opposite, sec theta is hypotenuse by adjacent, cot theta is adjacent by opposite. And there is a relation, cosec theta is the reciprocal of sin theta, sec theta is the reciprocal of cos theta and cot theta is the reciprocal of tan theta. Now, how to remember these trigonometric ratios? There is a simple tricks to remember this, that is OAO HHA, OAO HHA. One apple on his head, always. One apple on his head, always. OAOHHA. So students, consider here sin theta. Sin theta means what? Opposite by hypotenuse. Here O represent opposite, H represent hypotenuse, A represent adjacent. So sin theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, tan theta is opposite by adjacent and cosec theta. Cosec theta is the reciprocal of sin theta, so that hypotenuse by opposite. Sec theta. Sec is the reciprocal of cos, so that sec theta is hypotenuse by adjacent. Cot theta. Cot is the reciprocal of tan, so that cot theta is adjacent by opposite. So that remember this short trick, one apple on his head, always. Now you already know that trigonometric ratios have some standard angle from 0 degree to 360 degree. Okay, now next is trigonometric identities. There are three basic identities. First one is sin square theta plus cos square theta is equal to 1. And second one, 1 plus tan square theta is equal to sec square theta. Third one, 1 plus cot square theta is equal to cosec square theta. These three are the basic identities. And then coordinate system. These coordinate systems are divided into 4 equal parts and are called as quadrants. This is first quadrant, this is second quadrant, this is third quadrant, and this one is fourth quadrant. In first quadrant, all the trigonometric ratios are positive. And in second quadrant, sine and their reciprocal cosec are positive. And in third quadrant, tan and their reciprocal cot are positive. And in fourth quadrant, cos and their reciprocal sec are positive. Now, how to remember this quadrants concept? So, there is one simple trick, that is, remember this statement: all students take coffee. All means in first quadrant all the trigonometric ratios are positive. In students, S means in second quadrant all sine and cosec are positive. Take, T means in third quadrant tan and cot are positive. Coffee, C means in fourth quadrant cos and sec are positive. So remember this statement: all students take coffee. So in class 10th you studied like find sin A, cos A, tan theta, sec theta, cosec theta. That means only ratios are important. But in first PUC we studied sin x, cos x, tan x, cot x, cosec x, sec x as a function. For example, think of a function machine. Input, function, output. Input as angle. Input is angle. Function is trigonometric function. And output, whatever the values we get it. That is value. For example, if you consider angle is 30 degree, trigonometric function is sine. So, what is sine 30 degree value? 1 by 2. Now, if you consider 45 degree, tan, what is tan 45 degree value? 1. Now, 120 degree, cos. What is cos 120 degree value? Tell me, can we find cos 120 degree using a triangle? No. Yeah, no, because a triangle method works only for acute angles. To define trigonometric function for all angles, we need a unit circle. So we are using in this chapter, that is unit circle concept. Its complete explanation is available in our quadrantal angles video, so we won't repeat it in this lecture. If you need a better understanding, please watch that video first. Now, before we study trigonometric functions, we should first know how an angle measured. ನಮಗೆಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ, ಲೆಂತ್ is measured in meter, correct, and weight in kilogram. But angles ಹೇಗೆ measure ಮಾಡ್ತೀರಾ? There should be a unit, right? So we also need a unit to measure a angle. So that angle is a measure of rotation of a given ray about its initial point. Okay, suppose if you consider a ray, this is OA ray. O is a initial point, OA is the initial ray. And OB is terminal ray. So angle means what? Measure of a rotation of a given ray. So this is the given ray, OA is the given ray, about its initial point. Suppose the ray rotates OA to OB in anti-clockwise direction. So that we get the angle here, that is positive angle. So here we get it, positive angle. So that here the rotation is anti-clockwise. Now, if you consider a ray, initial ray OA, and then this is OB, this is initial ray, OA is initial ray and OB is terminal ray. So here the rotation is in clockwise direction, so that here we get negative angle. So rotation is clockwise. Now, measurement of angle can be done by two ways. Okay, one is degree measurement and another one is radian measurement. Now we will discuss degree measurement first. In degree measure, one complete revolution or one full rotation is divided into 360 equal parts. That means if you consider a complete one rotation, so suppose this is OA is initial ray, it completes one rotation. Now one full rotation is divided into 360 equal parts. See, one part, another part, next, third, fourth, fifth, like that. one complete rotation is divided into 360 equal parts, and each part is called 1 degree. Each part is called 1 degree. So observe here, this is 1 degree and this is also 1 degree, and here if you consider here, this is also 1 degree. So each part is 1 degree and it is written as 1 power small 0, that is 1 degree. So therefore one complete rotation, therefore one complete rotation is equal to 360 degree. Now observe these figures. In the first figure, OA is the initial ray. The initial ray starts from OA. After making one complete turn, it come back to the same position. Since one full revolution is completed, here the angle is 360 degree. Now observe the second figure. If the ray rotates only half a revolution or half a rotation, it reaches the opposite side. So here the angle is 180 degree, and for this case we get straight line. Now observe this third figure. The ray has rotates 3/4 of complete rotation. 3/4 of the complete rotation, so that here the angle is 270 degree. What if the ray rotate in the opposite direction? So that observe this fourth figure. Here the ray rotates in opposite direction, that is clockwise rotation. In this case we consider a negative angle. So the here for this figure the angle is minus 30 degree. Next, for the last figure, here the angle is minus 90 degree. Minus 90 degree. Next way of measuring the angle is radian measurement. So second one is radian measure. For this, consider a unit circle whose radius is 1 unit. Now, so radius is 1 unit. So here the radius is 1 unit. And consider a arc length. Consider a arc length. So here the arc length is 1 unit. So arc length is 1 unit and the radius is 1 unit. Now angle is 1 radian. That means as the arc length changes, angle is also changes. For example, if you consider next one, here the radius is 1 unit. Radius is 1 unit and arc length is 1.5 unit. Okay, arc length is 1.5 unit. Now the angle is 1.5 radian. 1.5 radian. So that means arc length for this diagram, arc length 1 unit, angle, that is we consider it as theta, is 1 radian. Radian can be written in the form of c upper so that is 1 power c, 1 radian. Now for the second diagram, arc length can be written in the form of L. L is equal to 1.5 unit, 1.5 unit, and angle theta is equal to what? 1.5 radian, 1.5 say radian. So what we can say that as the arc length changes, the angle is also changes, so that angle is directly proportional to arc length with the radius. So for example, if you consider the arc length is, in general we consider arc length is L and the radius is R. Now there is a relation between arc length and the theta, that is angle. So here the angle is theta is equal to L by R. Theta is equal to L by R. As the arc length changes, angle is also changes. So now for example, if you consider here arc length is, suppose arc length is 3 unit. Suppose arc length is, for example, arc length is 3 unit and radius we already know that that is 1 unit. So what we can say that angle theta is 3 by 1, that is 3 radian, 3 radian. Now what about for complete one revolution or complete one rotation? For complete one rotation, for complete one rotation, for complete one rotation means here we consider the boundary of the circle. Observe here, here arc length is, for the first diagram arc length is 1 unit and here it is 1.5 unit. Like that, for complete one rotation means what we have to consider here? Boundary of the circle, that means circumference of the circle, circumference of the circle. So here we consider circumference of the circle, arc length. For complete one rotation, arc length L, L is nothing but circumference of the circle, circumference of the circle, circumference of the circle. We already know that the formula, that is 2 pi r. Now we know that the formula, that is theta is equal to L by r. L is 2 pi r and the radius r, here r are getting cancelled, that becomes 2 pi. So that for complete one revolution or complete one rotation, angle is nothing but 2 pi. Angle is nothing but 2 pi. So one important note, that is for complete one revolution, theta is 2 pi, 2 pi is equal to 360 degree. So therefore angle is 2 pi, 2 pi is equal to 360. So therefore what about pi? 2 pi radian is 360 degree. Now what about pi radian? Pi radian is 360 by 2, that is 180 degree. And what about 1 radian? Pi radian is 180 degree, so that 1 radian is 180 by pi degree. 180 by pi degree. And what about 1 degree? 180 degree is pi radian, so that 1 degree is pi by 180 radian. So this is very important note. Remember this. 2 pi radian is 360 degree, pi radian is 180 degree, and 1 radian is 180 by pi, and 1 degree is pi by 180. Now next concept is relation between degree measure and radian measure. So if we want to convert into radian, if you want to convert the given angle in terms of radian measure, so radian measure is equal to pi by 180 into degree measure. And if you want to convert the angle into degree measure, that is equal to 180 by pi into radian measure. For example, for example, if we convert 30 degree into radian, okay, 30 degree into radian. So to convert it into radian measure, we have to use this formula, pi by 180 into degree measure. So here degree measure is 30 degree, so that pi by 180 into 30. Pi by 180 into 30 is nothing but 31, 36, that is pi by 6 radian. And this is first one. Next one, 60 degree. 60 degree is pi by 180 into 60, that is pi by 3 radian. Next, 45 degree. 45 degree is pi by 180 into 45, that is pi by 4 radian. And fourth one, that is 90 degree. 90 degree is pi by 180 degree, pi by 180 into 90, that is pi by 2 radian. Next, 270 degree, that is pi by 180 into 270, that is 3 pi by 2. These are all the some standard terms you should remember. You should remember these standard results, that is 30 degree is pi by 6 radian, 60 degree is pi by 3 radian, 45 degree is pi by 4 radian, 90 degree is pi by 2 radian, and 270 degree is 3 pi by 2 radian. So students, understanding the concept is only the first step. The real learning begins when we apply these formulas to solve the problems. In the next video, we'll solve different types of questions on converting degrees into radian and radians into degree. If today's explanation helped you understand the concept clearly, don't forget to like the video and share it with your friends. Subscribe the Vidmahi Maths Academy so you don't miss the next lesson. Until then, keep learning, keep smiling, keep practicing. Thank you, and I'll see you in the next video.